Jai Hind to everyone. My name is Vikas. I am an assistant professor in Department of Computer Science and Engineering. The topic that I am going to discuss is numerical on TCP and UDP of the transport layer. This is the overall picture where we have different layers are being there, and what are the various protocols that are being used or the different layers are just like a physical layer, data link layer, network layer, transport layer and application layer. So, we are focusing on here on the transport layer, and in this transport layer we are focusing on the TCP and UDP layers are there. As you already know, the TCP is connection oriented and UDP is connectionless protocols are there. The things that I am going to discuss today is types of numerical questions are being asked on this these two protocols are there, like your TCP and the UDP are there. Okay. In this generally university, most of these questions are generally being asked there. Okay. So, TCP is, what is TCP? TCP is a connection oriented protocols. It creates a virtual connection between two TCP to send the data. In addition, TCP uses flows and error control mechanism at the transport layers are. Okay. So, TCP generally is a connection oriented protocols in which once the connection has been established between the two nodes are there, and after the connection is established, the receiver and sender an acknowledgement back, then the sender will start sending the data are there or the networks are there. And during this transmission of data, the error control and flow controls are being done by the your TCPs are there, so that if there any data is being lost or is there any deviation or error in flow of control also there, that can also be sorted out by the your TCP protocols are there. Okay. So, this is a header in which we have this is the where this is a header there, and this is a data on which the data are being attached in the form of bits like your 0, 1, 1, 0 and so on are there. Okay. So, so this is here we initially define the source port numbers are there, destination port address are being defined there. These two are 16 bits are there. Then we have a sequence number which is of 32 bits are there. Then we have an acknowledgement bits are there, which is again this is a 32 bits are there. And we have the header length of the 4 bit here in this case, and here we have 6 bits are being reserved in this header formats are there, and these are the various bits on which we generally define what kind of type of informations that we are sending or what kind of information that is needed are just like your urgent, acknowledgement, push, reset, sync and finish are there. These are signals are being generated. Once if we are sending the acknowledgement, then this will be the 1 is there, rest of the are the 0 in this case. And if there is need for synchronizations of the data, again this sync bit will be a flag, or you can say flag will be up, and depending upon the nature what we are doing it at present situations at that instance at that time, these flags will be on or off, means 0 and 1 will be there. Then we have a window size is there which is of 16 bits are there. Then we have a checksum of 16 bit here in this case. We have an urgent pointers are there. Then we have an optional paddings are there in the this header format are there. So, here we are generally uses for this during the transmission of data is there. This is the format for the TCP layers are there. As these are the mentions, the flags are there. We have an urgent is being used for the value of urgent pointer field in the valids in order to validate that data is there. Then we have an acknowledgement which is used for acknowledgement field is there. Then we have push the data. Then we have reset the connection is being used for the reset is there, reset flag. If there is a reset flag is there, then we need to reset the connections are there. Then we have a synchronizations, sync flag is there, which is being used for the sequence number during the connections is being generated are there. Then we have a finish where it means we terminate the connections are there. Okay, so in this, these are the source port address and this is the destination port address. On the basis of this, there are well-known port addresses are there, on which we generally perform the using these port number, we can perform the task are there. Okay, so let's suppose we have an echo is there, we have discard, user, date time, whenever this port number 13 is being asked, then it will returns the date and time of the that machines are there. Okay, so the message will be generated by the from where it is being asked are there. Okay, so then we have an code change here, change the characters, return of the string of the characters are there. Then we have file transfer data and file transfer protocols for the control connections are there. Then we have a terminal networks, we use a telnet as being there. When we have simple made transmission protocols are being used, then we use the 625 port number is there. Then we DNS are there, port, the finger HTTP, RPCs are there. So these are the well defined or well known ports are generally being asked during the not during in the transmission of the data or transmission of message from one node to another node is there. So these ports, source and destination ports are being generally being written in this here. Okay, so the port number and address ports will be written there. Then UDP is again UDP is as it's says that it is an unreliable transport protocols are there, and it is also in a connectionless is there. Why it is being? Because in the TCP, let's suppose these are two nodes are there, so it sends the data directly to the this from A to B here in this case are there. Okay, so A will not, A only know the port address or an IP address is being known. Okay, so by using this IP address, it sends the data, and so that whenever the receiver will receive over the network, whenever it's A, send the data to the B's are there. Okay, so user datagram it is called unreliable transport protocols or connectionless protocols are there. So it does not add anything to services to the IP except the provide the process to process communications instead of host to host communications are there. One of the points with respect to transport your transport layer is there, the transmission of data will happen from the process to process are there. Okay, from means why it is being processed, because we need a port address are also being needed while transferring our data here. But in the case of network layer, we have a host to host communications are being done, because at that time only the IP address is being needed in order to transfer the data are there. So that's why here we call it the process to process communication instead of host to host communications in the UDP are there, as well as the in the TCPs are there. So these are the again these are well known protocols generally being asked there. Like your echo is protocols, we have if we receive a datagram back to the senders are there, we have discard any datagrams that is received is there. We have if another is users, active users are there, date times, again it returns the date and time of the given machines are there. Then we have quotes are there which returns the quote of the day is there. And then we have a CHARGEN, return the string of the characters are there. We have name server, boots, boot PS, boot PC are there. Here where it's define the server port, S define the server port, and C define the client port for the bootstrap informations in order to download it there. Then we have a TFTP protocols, is the trivial file transfer protocols are there. We have an RPC there, then we have NTP, we have an SNMP, and SNMP protocols are being used there. So, these are generally various well-known protocols are being used during the transmission of the data are there. Okay. So, this is the source pseudo headers are there. This is the headers are there because if you see in this pseudo header, we have a 32-bit IP address are being there and 32-bit destination IP address are being used, and we have all zeros and 8 bits protocols and 16-bit UDP total length is being used. This is with respect to UDP here there. This again like your TCP, in the UDP we have a port address are being needed. Also we need a destinations address are being needed. Why it is being? Because in the transport layer we have a process to process communications. For this we need a source port number as well as the destination port address are there. Okay. Then we have a UDP total length is there. Then we perform the checksums are there, and padding data are also being used there for while transferring of the this data are there. So, generally in general if any data is being transferred, they generally divide in two parts. One is for the headers, which is of the 8 bits are there, and the rest is for the data parts. Again in order in that header informations, the 4 things that is being needed. As it is in a transport layer protocols, we need a source address, source port number, destination port number, what is the total length is there, and what will the your checksum is there. So, source port number it is for the 16 bits are there. We have a destination port, again it will 16 bit, total length is 16 bits, and the checksum is again 16 bits are there. Data length will be defined by the length of the headers minus the data is there. So, what is the total length of the data that we can we have need to identify are there. So, you will better understand when we going to do the your numerical problems on this. So, generally the questions generally being asked over the university papers are there. In that, this is an examples I am taking is there. This is the hexadecimal format in which data is being sent using the TCP headers are being sent from source to destinations are there. Now, you need to identify is what is the port number out of this is there, what is your destination's port number, what is the sequence numbers, acknowledgement numbers, we have what is the header length hai, what is the type of length hai, what is the window size is there. So, for that first thing is we need to look into the block diagram of this in which we need to identify is or you can say you need to remember this format while solving that problem. Otherwise, if you do not remember this, then it will be very difficult for you to understand, or you know which number, which hexadecimal numbers will be used for the source port number, which hexadecimal number will be used for the destination port number, and so on. The sequence and acknowledgement, and most importantly in the TCP is this these flags are being used, what kind of flags are being up in this given hexadecimal numbers are there. Okay. So, let's take a questions. So, question generally the following is the dump of TCP headers in hexadecimal formats are being sent, and we need to identify the source port number, destination port number, sequence number, acknowledgement numbers, length of the header, type of the segments, what are type of segments are there, and the window size is being there. Okay. So, as this is the in hexadecimal number, we have to convert into the decimal numbers. First thing is that you should remember, before converting it, we need to know which numbers is being denote the source port number out of this given hexadecimal numbers. Which number is destination is there, which is sequence number is being used, which is used for acknowledgement, which is for the used for the length of the header, which is used for the type of segments, which is for the window size are there. So this is the again this is your format is there for reference point of view. We have a headers data are there, we have a source port are there, we have destination, sequence, acknowledgement, so on are there, which is already being discussed. So first thing is we need to identify the source port numbers are here in this case. Okay, the source port is there as it is a 16 bits are there. So for this we know this is for the source port numbers are there. Okay, so these 4 numbers are for the your source port numbers are there. So 1 digit is for this is a 4 bit 4, 4, 8, 12 and the 16s are there. Okay, so as the source port number is 16 bit is there. So for this 16 bit we choose this first 4 numbers, that is 0, 5, 3, 2. Is your source port number is. So now we identify out of this given hexadecimals numbers, the first 4 bits are being used for the source port numbers are there. How we identify? For one this 1 digit, it is for the 4 bit are there, and for the source bit we need 16 bits are there. Okay, so when we add these 4, 4, 4, we get the 16. So this is the first values there. Now as 0532 is the number is there, which is identify the source port number. So as the source port number is 2 byte long, we are able to identify that this is the source port numbers are there. So the source port number is first 4 hexadecimal digits, that is your 0532 is the, if we convert into a hexadecimal number, then we will get the this numbers are there. So this is the source port number in terms of decimal numbers are there. Okay, now again we have to come to the destination port number. Now again the destination port number is again it is a 4 bit 16 bits are there, and we needed a next 16 bits are being used. So next 16 bits are 0017 are there. So again 0017, and it is 2 byte long. In 1 byte we have an 8 bit are being there. So it is 2 byte long field are there, which is used to identify the port of the destination packet. And the destination port number is the second 4 hexadecimal digit, that is 0017. If we convert into the decimals, this hexadecimal number into decimals, we will get the 23 is there. So 23 is the number decimal number with respect to this hexadecimal number. So this is the for the destination port number. The port number is 23 is there. So if we look into this, so TC23 is the port number, destination port number that is being used for the telnet is being used here for the flag, that protocols is being used here in this given hexadecimal numbers are there. Okay. So next is your sequence number. Sequence numbers again it is 32 bits are there. So it will be your these 4 bit plus these 4 bits are there. So this will be your sequence numbers. Again it is a hexadecimal number 1 is there. If you convert it into a decimal, it will be come out in a 1 again here. So it will get the 1 is. So sequence number is 4 byte. And 1 byte we have an 8 bit, and it is 16 bits. Sorry, 32 bits is there. So we convert into decimals from hexadecimals, we will get the 1 is there. Now another next we need to identify the acknowledgement as per this given header format. Again it is 32 bits are there. Now we have to see the 32 bits. Again, these 32 bits are 0, 0, 0, 0, 0, 0 are there. So the sequence number will be 0 are there. Okay. So now we have to next we have to identify the header header are there. So as this is there, header is the 5 here. This next number is 5 here, and the we have a hexadecimals, as we know. This header length is the your 4 bit. So we have a 5 is there, then we convert 5 into 4, then we have a 20 bytes is being allocated for the header is there, because since it is a measure in the 4 bits, so we simply multiply the 5 by the 4 is there. Okay, so this will defines the what is the length of the headers are there. Okay, so next is we need to identify the type of the segments are there. Okay, so if we look into this, this is the 5 0 0 2 is there. Okay, so we need to identify from out of this in order to what kind of flag or what kind of segments that is being up here in this case. Okay, so in order to identify, first thing is we need to convert this 500 into these bits formats are there. If we convert to 5, then this will be this 0 is already know we know 0, then we have a 0 is there, then 2 can be converted into in this formats are there. Okay, so if we say this first 5, if we say 5002, we have taken this is here 16 bit. So in this 5 is already being taken. Now we left with the 0 0 and 2 is being left here. Now in this, if we convert it in this, the first 6 bits are being used for the reserve here there. So 1 2 3 4 5 6 bits are being reserved are there. Now we left with the 4 5 6 sorry. Okay, now we left with the these two. Okay, so in this sorry, let me write down here, it will be better. 5002, it will be 0 1 0 1 0 0 0 0, then 0 0 0 0, then a 0 0 1 0 is there. Okay, so this already being considered for the header length, so we will not be considering this. Now 6 bits are being reserved, 1 2 3 4 5 and 6. So these 6 bits are being used for the reserves are there. Now the 6, now we left with the 6s, 1 2 3 4 5 6. So 1 2 3 4 5 6 bits are being left for the in order to identify what kind of segments are being there, before need to identify. So we this is for the urgent are there, this is for the you say the urgent, this is for the acknowledgement here, this is for the push, this is for the reset, this is for the sync, and this is for the finishes are there. Okay, so as it is being seen here, this bit is 1, rest are the zeros are there, any they are off, and you can say these are the off, this is the on are there. So sync bit is on here in this case, so we say type of the segment is sync here in this case. Understood how we calculate it? First thing is we need to identify what kind of number is there. After identification of numbers, we need to convert into these binary numbers are there in the form of bits are there. Once the bits are being identified, now we need to look into the how many bits are being for reserved and how many bits are being for this, and out of this left of the 6, which one is up, which one is not up of that. So according to you need to identify type of segment. So we have a type of segment is sync here. Again, we need to identify the window size. Window size for the next is 07FF, which can be converted into 2047. This is the decimal number. 07FF is your hexadecimal number. So this is the diagram in which this is problems that we generally can have in the university papers are there. Another is for the TCP, it is for the UDP is there, where we have an again, this is the hexadecimals format data is being received. Now we have to identify the source, port number, destinations, length of the user datagrams and length of the data is there. Okay. So for this again, we need to identify the source port number is here. If we look into the, this is the header is there. Okay. So header format is being given to you. You need to remember it. Otherwise, it will again, I am saying it will not be, it will be very difficult for in order to identify what is the source port number, destination number, length or checksums are there, or you can say destination IP address or anything that is being asked. So you need to remember this header format for this. Okay. So again, this is the source port is 2 byte long, as it means 16 bit is there. So we need to identify the port number of the source, and the source port number is first 4 hexadecimal is your 0632, and if we convert it into hexadecimals, we will get the result 1586 is there. So 1586 is the source port number is there. Okay. So again, we need to identify the destination port number, and as it again is 16 bit, so it is 2 byte long here, and next 4 bits that is being we have received for the in the form of hexadecimals are the 000D are there. If we convert this into a decimal number, we will get the number is 13 here there. Now we have to identify the length of the UDPs are there. So the length of the UDP includes the header and the data, and it is 16 bit field is there, and we receive the hexadecimal number, this is there, 001C is there. So if we convert this into decimal numbers, so length of the whole UDP packet will be 28 bit long. So no, not 28 bits, it's a 28 is there. So again, the length of the header is there. As we know, header is of 8 bits are there, and so the length of the here the data, not it will be header, it will be must be data is there. Okay. So here 8 bytes are being fixed. So total length of the out of data will be 28 minus 8, and the 20 bytes will be used for the data are there. So generally these are the 2 questions are generally widely used asked in this kind of university papers are there, and again these are another examples in which we have an UDP for header formats are there, in which we have these 2 hexadecimal formats data is being received. Now again we convert this hexadecimal into a decimal number. So this is for this, this is the decimal number for this, this is the decimal number for this, this is the decimal number for this. Again we need to 28 minus 8 is 20 byte long is the length of the data is there. Another examples again, same again we have a header hexadecimal numbers are being there. We need to identify the source, destination, length of datagram, length of the data is there. Again this is the hexadecimal, this is the decimal numbers we need to convert it into. This is again for the destination port number, this is the port number that we need to identify. Again this is the hexadecimal format for the in order to identify the length. So UDP packets is 28 bit are there. Again length of the 28 minus 8, it is your 20 bytes are being used for the data length here. Thank you.